Hey everybody, it's Masai here, and today we're going to talk about hallucinations. Hallucinations have been a topic of a lot of discussion in the legal field, in all fields really, because in a lot of enterprise use cases, the one biggest blockage or concern is hallucinated outputs, obviously. So today we're going to talk about hallucinations, about what they are, why they happen, and then the tools that you have at your disposal to try to mitigate hallucinations as you're thinking about incorporating AI into your legal practice, as you're thinking about building out different AI applications and different workflows. It is important to know what tools you have at your disposal that can help you to mitigate the risk of hallucination. And I also want to make a quick comparison between software development and the legal field. Obviously, if you're developing software, if you're writing code, if AI hallucinates the code, then the code just won't work, right? And yet still, a lot of software developers, I would venture to say most software developers are using AI in a very extensive capacity to help them write their code. So I just want you to know essentially that it is possible. It is possible to use AI to operate and work with AI in a way that AI does give you accurate outputs, because again, obviously if AI hallucinates in your code, it just doesn't work. But people are able to write code and use code and deploy code with AI that is working well. And I'm also confident that in the legal field, you guys can work with AI, you guys can build legal applications with AI, and you can use AI in a way that it is accurate and precise and in a way that it works, right? So I'm going to take some of the methods that people use in the software development industry, and we're going to apply some of those to the legal field and think about employing those strategies to reduce hallucinations, right? To not get hallucinated citations or just to not have AI making stuff up in your legal practice. So before we get into covering hallucinations, there are one or two things, just baseline things that we have to understand about LLMs and how they work. Because what we're trying to understand is, why do AI models sometimes generate outputs that are incorrect? Which means we have to understand how they generate outputs in the first place, which means we have to understand something called tokens. So I'm going to explain tokens to you now. Okay, so quickly on tokens, it is really important to understand this before we talk about hallucinations. Without understanding tokens, it's very difficult to understand hallucinations. So tokens are how language models break down inputs, right? So an oversimplification is saying that tokens are like the vocabulary that the model has. Language models don't store words, they store tokens. Obviously, we have this message here in English, and we can see that each of these colored sections relates to a token. So hello is being stored by the language model as this number here. Everyone is being stored as this number. And so a language model like GPT-4 has about 100,000 different tokens like these that it uses to store meaning. And so you can see here, it's not necessarily just word for word, because something like YouTube, we can see the U is in gray and it corresponds to this token here, 1608, and then tube is in purple and it corresponds to this token, 13151. So these are tokens, and this is how language models store information. Okay, so those are tokens. And so we can start to think about language models having a certain amount of tokens. You can think of them as like AI words, but you can start to think about language models as having a certain amount of tokens in their vocabulary that they can access. And so what's happening every time a language model is generating an output, based on the context and based on the question that's being asked, and also based on the information it's been trained on, what it's doing for every single word or every single token is it's looking at all 100,000 tokens in its training set, and it is assigning a probability to each one of those. And that's how the language model goes and is able to produce outputs. Based on the probability of which token is going to come next, it's able to choose from that token, and it does that over and over and over again, and that's how it generates output. But the really important thing to understand is that AI is probabilistic, right? It's not deterministic. So, for example, if you were to ask me what the best instrument is, whether you ask me on Monday or Wednesday or Friday or Sunday, I'm always going to say that the best instrument is the piano, in my opinion. But if you take an AI model, right, and let's say the AI model in its probability distribution, the best instrument in its training set 60% of the time is guitar, 20% of the time is violin, and let's say 10% of the time is ukulele. If you ask that language model 100 times what the best instrument is, then 60% of the time it's going to say guitar, 20% of the time or whatever I said is going to say violin, and then 10% of the time it's going to say ukulele. It's not always going to give you the same response to the same question. And so this is inconsistency. So that's one of the effects of AI being probabilistic and not deterministic, is that you get this inconsistency where you can ask it the same question and get two different answers at two different times. Another consequence of AI being probabilistic are hallucinations. And so hallucinations, as you guys probably know, is when AI comes up with an answer that's not real. And so there are a couple of main hypotheses on hallucinations and why they happen. I'm going to touch on those quickly so you can understand what causes hallucination. One of the main hypotheses is self-delusion, or what we can call also snowballing hallucinations. So basically the idea of self-delusion is that the idea behind self-delusion is that the AI model cannot distinguish between the facts it has been given and the output it has created. Let's say, for example, you train an AI model on the best types of seafood, for example, salmon, crabs, shrimp, lobster, all the different types of seafood, right? And then you have a conversation with the model where the model says something that is incorrect or false, like crabs can fly, right? The idea of self-delusion is that the model can't tell the difference between the things that it has said and the things that you taught it. And so it takes both of those things as gospel, basically. It made a mistake and said that crabs can fly, but it's going to take that just as seriously as the information you gave it previously about, all the different types of seafood. And so what happens is you get a snowballing hallucination where the model says crabs can fly, and then it makes up a bunch of other things that support its false assertion that it made before. So it says crabs can fly, then later on it says crabs have wings, and then it says crabs are also a type of bird or something like that. It just snowballs the hallucination. The other hypothesis is that delusion or hallucinations are learned in the fine-tuning process because of a mismatch between the model's internal knowledge and the labeler's internal knowledge. You can kind of imagine that in the fine-tuning process, a language model is learning to copy the behavior of a human labeler. Let's say for a model that has to do classification of spam emails and non-spam emails, right? What's going to happen is you're going to have a human labeler that's going to go over emails and label them as spam and not spam. Those labels will then be passed to the model so that the model can learn to copy that behavior. But what happens is if the model doesn't have the same understanding as a human labeler, it's essentially learning to guess without actually understanding what it's doing. It's learning to copy outputs without really understanding why those outputs are correct. In the fine-tuning process, models can be being taught to hallucinate because they're essentially being taught to guess things that they don't know for certain. So those are the main hypotheses about why hallucinations occur. Now I'm going to give you the tools to mitigate them, and we're going to talk about how you can go about doing your best to prevent hallucinations as you're working with AI in your firm. So the first tools I'm going to give you to be able to mitigate hallucinations in your AI applications and whenever you're using AI are sampling strategies. I'm going to give you 3 sampling strategies today. As you're using AI in your practice, these are things that you can start to tweak and start to think about. For example, if you're building your own assistant in OpenAI, they'll give you the ability to change the values of some of these different sampling strategies. So I'm going to cover those now. The first one we're going to talk about is temperature. And usually you'll see temperature as an option between 0 and 2. Basically, the higher your temperature is, the more creative the output is. What temperature does is it gives more probability to the more rare tokens, and it gives less probability to the more common tokens. So if you turn the temperature all the way up, we might get an output like the cat sat on a kite, right? Which would be a very rare output, instead of the cat sat on a mat, which is a very common output. So the higher you raise the temperature, the more creative the outputs will be. And so especially in the legal field where you may not want that much creativity, obviously the higher your temperature is, the more risk of hallucination you have. By lowering the temperature a bit, you can start to mitigate the risk of hallucination. The next sampling strategy we're going to talk about is top K. Top K basically just means that every time a generation is happening, every time the language model is saying something, it's sampling tokens from that vocabulary of 100,000 tokens. And so what top K is going to do is it's going to limit the tokens that can be used for sampling. So if we set top K, for example, to 500, then instead of sampling from all 100,000 tokens, only the 500 most probable tokens will be used for sampling. So again, this is something you can use to tweak to make your outputs a little bit more consistent, a little bit more deterministic. And then top P is a little bit more flexible than top K. Top P is basically including all the tokens, including the smallest amount of tokens required to reach a certain probability percentage, right? And so you usually see top P being a value between 0.9, 0.95, somewhere around there if it's used. So top P, again, is something you can use to make your outputs more deterministic. The lower you bring top P, then the more deterministic your outputs are going to be. It's also been shown that the more you lower top P, so if you get down to a 95 or a 9, the outputs do a better job of being related to the context around it. So obviously we have all of the sampling strategies from before. You have temperature, you have top P, you have top K. Then you also have prompting as well. So you can prompt the language model to respond that it doesn't know, right? So you can tell it just in a prompt, listen, if you don't know, if you're unsure of the output, just say, I don't know. We have RAG plus verification. RAG is when you give your agent a database that it can pull information from, whether it's your internal documents or specific documents that you give to your agent. You can also tell your agent to verify its sources. You can have it verify which source it actually pulled that information from and why it's saying exactly what it's saying. And then the other one is using AI as a judge. You can have a workflow where you have one AI agent that is responsible for generating a response, and then you can have another agent that is responsible for checking the response of the first agent. And that agent could ensure that the response is accurate, that there's no hallucinations in the response. And then also, if the response needs to be regenerated, then the second agent could just give its feedback back to the first agent. They could iterate that process over and over again until they're able to produce an output that actually is sound. So those are the main tools at your disposal to reduce your risk of hallucination. Again, if you are a solo attorney and you would like my help figuring out how to implement AI into your firm, there is a link in the description. You can click on that and get more information there. Please don't be shocked. It is me putting on a sales hat and trying to sell you something. So that's there if you want it. So if you enjoyed the video, leave a like. Obviously, it helps me out a lot. It also helps YouTube to show you more videos similar to this one if you are, trying to learn more about AI and law and that kind of stuff. Leave a comment. Also, let me know any other videos you want me to make. If maybe some diagrams or some photos would be helpful. And then subscribe and also turn on post notifications so you don't miss any videos like these or any tutorials or anything that comes out. That's pretty much it. I thank you guys from the bottom of my heart for watching this video and I hope you guys have an amazing day.